identify and recognize the entity, including human beings, device, car, and other types of moving objects in the physical space we are in now at this moment. At first, I will explain the introduction, and there are a few assumptions in this paper. So at the next step, I will identify the assumptions. I will introduce the overview, and I will describe the collaboration or related identities, handover, ID management, and I will conclude. As you know, the ubiquitous computing service is expanding into our real lives and society. So the motto of ubiquitous service is anywhere, anytime, with any device. It means that the user convenience and the seamless service provision is designing and developing current service. Also, the majority of IT technologies are focusing on service. And there are some research trends on convergence of IT space and physical space. In the past time, the IT technologies are only focusing on the logical space, but at this moment, the IT technology is not limited to logical space. It is expanding into the physical space. I will explain the description, the details in the next slide. And most services are based on the identifier of entities. Especially authentication is essential in providing security services and many types of applications. So there are a few authentication mechanisms. For example, there is a ID password-based authentication mechanism, which is very generally used by us and very simple, but it is supposed to be less secure than other authentication mechanisms, such as certificate-based authentication or biometric-based authentication mechanism. So in this slide, I will explain what the surveillance system is. The surveillance system monitors, controls, retrieves information about our real lives with surveillance system. Latency system gathers video information and stores it into the designated storage media, such as video server, DVR server, etc. But intelligent system recognize and keep track of the object, status, event, and other actions, etc. The intelligence system is one of the most interesting research topic in the surveillance system. So also, there is an increasing trend that requires more system because anti-society crimes are increasing and other technologies are based on the CCTV. Surveillance system is responsible for the security in physical space. So this slide explains the main purpose of our system, our proposed system, the convergence of ID and the surveillance system. The legacy authentication mechanisms don't support the user convenience. It means that if there is a physical area or the logical area, there are few application services, and each application service adopts its own authentication mechanism, such as ID password-based authentication mechanism, certificate-based authentication mechanism, etc. So if we are going to use them, then we we have to authenticate it at every entry of the application, so it results in significant user inconvenience. So, and the of course needs a seamless service and user convenience. So we needed to integrate the benefit of enforcement of CCTV and various authentication mechanics. So we propose a model for enabling identifier-based application service with the help of intelligent surveillance system. I think I had an unused microphone. Sorry. Sorry. There is a few assumptions in this paper. The first is each space is monitored at least one surveillance device like the CCTVs or enforces a corresponding authentication mechanism. And each CCTV provides functions for collaboration without the CCTVs for relaying entities' identity-related information. And various authentication applications may communicate with other CCTVs for sending and receiving identity-related information. So this slide, I don't know, so not so much time, so I'll skip it. This slide describes the overview of this paper. Actually, our proposed model is physically composed of multiple spaces. Each space can be categorized into two types: authenticated space and not authenticated space. The authenticated space adopts a specific authentication mechanism, and the not authenticated space doesn't support any authentication mechanism, but just monitored by the CCTV. So there are a number of services based on the identifier in this proposed model: authentication service, authorization service, reinforced healthcare service, object monitoring service, and network service, and etc. So this slide describes the collaboration for relaying identity. So in this figure, there are three spaces: space A, space B, and space 1. Space A and space B are authenticated space, and space 1 is not authenticated space. So if the entity is moving from the space A to space B, then it should go through the space 1. In this scenario, this entity is moving from the space A to space 1, then the authentication mechanism in space A send the identity-related information to the CCTV in the space 1. Also, the CCTV keep track of the moving object. So also the entity is moving from space 1 to space B, then the CCTV send the identity-related information to the authentication mechanism enforced in space B. So also this slide describes the handover through multiple not authenticated space. This figure is composed of three spaces. All spaces are not authenticated space. So if the entity is moving from the space 1 to space 2, then the space 1 sends the identity-related information and the PII to the space 2. Also, the entity is moving from the space 2 to space 3, then the space 2 sends the identity-related information and the PII to the space 3. In this figure, PII stands for physically identified information. So it may include the identity type, person, car, device, and other types of entity, or it may include the physical appearance of the entity. For example, physical size, color, shape, or cloth, hair, and plate number, and etc. And it may include geometric location of the moving entities. Also, this is depending on the application of this system. Also, this this entity is moving from space A to space C, then the identifier of the entity is relayed from space A to space C. In this scenario, the identifier of the entity is generated in space A, but this is used in space C. So, to make it possible, the identifier must be valid in space C. So we make it possible. We build a hierarchical structure called UIDM, Universal ID Management. So this is a proposed hierarchical structure of the ID management. So actually, the specific ID management may use adopted various existing ID management protocols. This is just a proposed conceptual model for ID management in this system. So this is a conclusion. And in the current environment, we couldn't guarantee that every application supports our authentication mechanism. Also, it results in user inconvenience, significant user inconvenience. So we need a new way to identify and recognize an entity. To identify an entity in the Euclid service environment, each system maintains identity-related information and relates it to other systems when the entity traverses vertical spaces. And it provides a structure for global identification. Thank you. That's it. Any comments or questions?
Okay, thank you very much. Any question, please?
That's very interesting topic. And I have two questions. The first one is, how can you divide the authentication surface and non-authentication space? Because there's no clear cut edge between the authentication space and the non-authentication space. Even though we can divide that by geographical positions, but there is some overlaps. So that is my first question. The second question is, even though you have some assumption in each space is monitored by at least single surveillance device like CCTV, but usually when we think about the ubiquitous devices, there are several small or several mobile devices such like PVC and PDS and some sense, even though in sense was UMPC. So by using the CCTV, we cannot check all the movement of devices. So how can you solve that problem?
Okay. The first question is, I think so. And the spaces made duplicate spaces. I think so. I hope that this is the best condition, I think, because if the spaces have the duplicate, then it can be very easy to trace the object. So it is a desired condition. So I think the second question is, you mean that the difficulty of tracking of the small object devices, right? So in this paper, so I propose a tracking of the object, moving object. So actually this includes a small device such as a PDA. So I know that this is a little bit difficult to trace the small devices. So this is focusing on the big entities such as human being and the car and other systems. So actually I know that this may be a little difficult in tracing. So this is depending on the technology, universal technology.
But usually when we consider the ubiquitous devices, usually the device is very small and just we can carry it in the pocket. So it's not easy to
I know that, but
monitor and check.
we use the terminology first, but this is the surveillance system is generally focusing on the human being or other a little bit big which can traverse all the physical space by himself. This is the general consensus in the surveillance system. So once your comments may be very beneficial to our proposed system.
Any questions? We got time for 1 minute for last questions. Okay. If you got any question, please Mr. Won Woo Kim after presentation. Got 3 papers to go to present. Thank you very much, Mr. Won Woo Kim, for methods and communications research institutes that you college. Thank you very much. The next presenter is Mr. Chun Chun. Mr. Chun Chun. Mr. Chun Chun come from Pusan National University from Korea. We to present 3D applications and localization of objects in a single image.
Good morning, everyone. My name is Han Jang in Pusan University in Korea. It's my pleasure to be here. Today, my topic is 3D approximation and localization of objects in a single image. As you know, there are extensive researches on 3D object reconstruction from multiple views, such as stereo vision or space carving representatively. But in most cases, we can get only one view of an image or a scene. Moreover, these methods are so time consuming, so we can't apply this in real time.